what makes this chain unique is what we have is what we call a hybrid consensus mechanism on a multi-layered blockchain. So what this means is we have a delegated proof of stake and we have a proof of work component. The chains we call the fast chain and the slow chain. So the fast chain is all about doing the transaction validation. We're doing 5 seconds per block, few hundred transactions per block. Once the block is validated, there's the proof of stake, which is the component of a additional authentication to sign off the signature of the transactions. So from there we move into how the transactions then come into. Oh, it's very distracting, guys. What makes this chain unique is as I said, the transactions are much faster than what you find in other traditional chains out there. One of the things, another benefit that we have with this chain is our gas fees are quite a bit lower because we set the gas limit appropriate to the number of transactions. Another thing about this chain, which is quite unique, is, okay, let's see. Okay. So because of the speed of the chain, we right now are doing around about 10,000 transactions per second. We believe we can hit 150,000 transactions per second, which is pretty remarkable that we've found so far. Excellent. Okay. As I babbled, trying to work my way through the presentation in my head, I can now give you a little more structure here. So anyways, first I'll walk you through how this works. So as I said, there's the fast chain, which is made up of a committee that are selected by a level of staking. Once they validate this, every 5 seconds, it gets dropped into what we call fruit. And the fruit is basically just a record of all these transactions. From the fruit, the slow chain will go and do the validation on the fruit and sign off on it. So one of the things that we're all really aware of by now is to have a blockchain that really thrives in the future, you need the ability to be cross-chain interoperable. So this is another thing we've built into the chain right now. The way we do this is we have multi-sig contracts to bridge for the assets from other chains. So as we built this out, we really wanted to develop an ecosystem, a decentralized ecosystem that was competitive with a lot of the things that are out there. You know, and I'm sure you've heard from a lot of different chains out there that claim that they have all these things. We've actually built all these things except for the very last one, the NFT Marketplace. That will be later in the summer. So starting off with our stablecoin. So we call this aCash. So aCash is a stable token that is pegged to the dollar, and we have the ability to then convert the ACT to USDT. And the AST is minted by purchasing it with any of the popular cryptos like Ethereum, Litecoin, Bitcoin, etc. So, you know, having a good blockchain, you have to also have a strong, robust smart contract process. This is another thing that we have that we've been working really hard on. We really want to make this very easy for users. So we have a very easy user interface to be able to build these smart contracts. So, and again, as I said, we have a low gas fee because of the level of transactions. So one of the exciting things about what we have, I think, it's one of a really unique thing, is a alternative to a decentralized storage application that's based on IPFS. So essentially what we've done is we've created an incentive layer on this the IPFS. With this incentive layer, we reward in the AST. The AST can also then be, we have a one-to-one parity with Filecoin. So as you earn ASTs, if you want to move them out into to Filecoin, you can. And this is actually our first example of our interoperability with another chain, and many more to come. So to step through, for those of you in the audience that know a lot about this, this is going to be very simple. So the very basics of how this works is a user pays a miner to store the data. The miner commits data, and the network validates, and then the user pays the miner to retrieve the data. So really, from what you've seen out there, it's really not much different than others out there. Oh, actually, I want to go back here. One last point I want to make. One thing that is different about this, I forgot to mention, is so we have an application that will allow our miners to be able to basically access pre-configured nodes. This is pretty big because with some of the other players out there, it can be pretty complex. I mean, IPFS has some really strict requirements on how you set up your nodes. What we've done is we're making it very easy for the miners. We have these pre-configured nodes. You can go in as a miner and start rolling right away. And what this means also, because you're not responsible for all the restrictions that come along with IPFS, you'll never have fines. So, of course, there's the DeFi aspect. So we actually now we've been building out, and we have in operation a DEX, but we'll be building out this more and more. Right now, XSwap does have compatibility with all the major wallets out there. So one of the things, another really exciting, in addition to storage, that really excites our team is we now have the domain music.net for NFTs. This is a really interesting play because it's going to be specifically focused on the entire music industry. So it's not just individual artists, it's going to be anybody that's involved in music. The process is a very simple 3-step process. You, as an artist, you come in, you go into a form, answer a few questions, and you step through, and the next step, you upload your asset, and then last step, our team goes in and validates the assets that's been uploaded. The other thing that's really cool about this that we haven't seen out there is we do support digital rights contracts. So part of those questions, we start to build that digital rights contract. And the way it's structured from a standpoint of copies, you can do 100 up to 100,000 copies. So coming to an end here, there's one last thing I wanted to announce. So we're using this conference to make a big announcement with music.net. There are many other things that we'll be doing in the future, but our first big NFT release is going to be the Grammy and AMA award-winning Naughty by Nature. We have many others coming up, so it'll be a very interesting journey with music.net. I hope you guys will be active users, and you can find us. Let's see. Here's some places you can find us. We currently are trading ABAY on ZBX.com and ZBX.plus, and we are working on rolling out into other exchanges out there. So guys, again, thanks. My apologies for the issues with the slides. I think we both survived, so thank you very much.
Neurothink, making machine learning radically accessible. With Charles Donnelly, Neurothink.
Hey, good afternoon, everyone. If you learned anything about Brian and our company, we're definitely flexible and adaptable. So that was a great job, Brian, for getting through the presentation there with the issues. When Brian was recruited to help ADX get into machine learning, he had a vision for a platform. That platform would be streamlined, efficient, and powerful solution for a wide variety of people could get access to make great machine learning. Much of that vision came from his time when he was at the Machine Learning Society in New York, working with the teams there. He saw the difficulties the data scientists had in being able to get the important GPU compute power needed to make the best models. We'll discuss the challenges and some of the issues with those solutions today, but as an example, for these expensive GPU compute power, only 15% of it ever gets used. 90% of all models never get put to use. And data scientists are the most coveted engineering resource today. So the reality is only about 1% of our most desirable resource gets used. So we know we can do better than that. And that's why I joined Brian a few months ago after he started. Okay, plan B. I'm going to talk about Bassett Energy, which is not my company. Is there something I should do up here? Okay. No, this is not our company. I will take this moment to point out that at 6 o'clock, we'll be at the Vista Lounge for happy hour, which sounds like a really good option at this point. So it's right at the lobby of the Intercontinental Hotel. Hey, there we go. So close, yet so far. And we're going to give away awards. I think we're getting there. Let's start with the discussion about this era of machine learning and what it can do for us. We'll also talk about some of the challenges and limitations. Machine learning is often thought of as the math that creates cats from the internet. But the reality is machine learning can do a lot more. Today, if we look at the applications of machine learning, there are a lot of them just in your pocket. Credit card companies today are able to use machine learning to make fraud detection a reality, and that decision has to get made in less than 10 milliseconds. Pretty fantastic that you can apply machine learning in something that is so quick. It can be used in factories to determine product quality. In the automotive industry, it saves hundreds of thousands of dollars at these factories. People that work in the factories can take pictures of defects, they can send them back to the server networks, it can be annotated, and then that new information can be spread around the world to factories automatically. And maybe more interestingly, NASA in their satellite system, they're applying machine learning today to be able to predict the causes of forest fires in the Amazon. So officials can look at the ones that we think are man-made. And that data set is not looking at days or months. It's tracking year over year changes in the Amazon to be able to make these types of predictions. Our NeuroThink platform will support all these types of models and categories of data. Let's just look at how powerful it is. Machine learning, especially deep neural nets, use a string of probabilities to come to most likely conclusion. We're talking hundreds of millions of calculations and suggested answers. But we need powerful computers to run these large, deep neural networks and also be able to do the reinforcement learning. The reinforcement learning means to be able to change these values millions of times to get to the right equations that are able to predict what we're looking for. And data sets actually need to be broad enough to not just care about what you are trying to categorize, but we want to also include data that's outside what's intended. For example, if you're collecting categorization for food, you may have to include data sets you don't even think about. And that's so that when you don't confuse your breakfast for your pet. This is a real issue in data analysis. In the last 10 years, the powers of these models is growing 4 times faster than it was in the previous 50. And this graph is on log scale. Every line is 10 times more powerful than it was before. So the last 10 years, we've been able to see the compute power to finally make these models a reality. But even with these most powerful GPUs and the cost coming down, the cost to make the model is rising rapidly. It's in the millions of dollars at this point. And this means that these models are in the hands of a very small few set of people who can create them. NeuroThink is going to give greater access of these models to the rest of the world so these can be retrained and used in your business cases. The industries that can benefit from this are broad. And the promise of machine learning is it can cover a greater range of exploration than any group of humans. But it's not just machine learning. You need machine learning to stumble upon discoveries, and humans can then apply their intelligence, understanding, and guidance to make use of it. It's really a combination of the two. The opportunity is estimated to be an increase in the global GDP of $15 trillion in the next 10 years. And that's not just from quality or productivity, but it's in personalization of the products and solutions that are going to come from this. I'm going to go further in saying that this is not just a cost play. Machine learning can save this world. Let's just take an example. You don't have to go to Mars to discover new things. We only understand about 1% of the Earth. Most of the life on this Earth comes from the oceans. We understand almost none of it. One of the companies we're working with that was just in Forbes last week, TerraDepth, they have a technology to persistently stay out in the ocean and collect data. Humans can't stay out in the ocean for very long. So with this type of technology, you need machine learning. Why? Because now these vehicles have to autonomously be able to navigate out there by themselves. They're collecting data, terabytes of data a day, petabytes over a week. You can't send that back on a satellite link. The data is out at the edge. So you need the machine learning also out at the edge to calculate and understand that's interesting. I want to save this data. I want to send back a signal, and then people can monitor that and redirect the autonomous vehicle to continue to collect data. And it's not just about mapping the oceans, it's about being able to track the aquatic species that are down there. And it's even sensors to be able to look at salinity and temperature and carbon dioxide that's being absorbed in the ocean. And as you collect that data over time, we're going to start to understand how important the ocean is to us. Let's take a look at what one of the leading companies, OpenAI, doing is in AutoML. So they moved from just working in the digital space. They were able to take a robot arm from 15 years ago. They provided no special engineering constants. They used no robotics engineer. They used no kinematic equations. They went through progressive training of teaching the robot in the digital space with machine learning to hold something, not to crush it, not to drop it. They then progressively are able to advance that and teach it what a Rubik's Cube is. Then they're able to teach it how to solve the Rubik's Cube. But it's really teaching itself as it goes back and forth. And in each of these steps, what's new about this is they modify the data, it creates more variance, and then they retrain it and redeploy the model. The outcome is actually a fully functioning solution. What you see here with the plush giraffe is that it's changing the Rubik's Cube, but the robot arm just goes ahead and solves it. It was never trained to do this. It just knows how to do this because the models are becoming so robust. So the implications for real life business are awesome because now machine learning models can work in more unexpected situations than ever before. This didn't exist 3 years ago. What hurdles are we facing? So there's 100 billion stored and linked values that are hard to understand in these equations. We try to use methods like dimensionality reduction to understand them. We think about our own world that we live in. How many dimensions are we in? 3, up, down, left, right, forward, back. You're going to argue with me 4. Time is another dimension. And there's color, maybe what we smell. There's like 6 or 7 dimensions. These models have thousands and millions of dimensions. So fundamentally, it is a real issue. And the founders of Darwin AI said, output alone is insufficient to understand what the model's doing. It's just very opaque by its nature. Let's just take a simple example. So here's a model that was shown in KubeCon last year by a director at Microsoft. It's trying to determine husky or wolf. It's over 80% accurate. And this case, it got it wrong. So you say, why is that a husky and not a wolf? Why did the computer not get this right? What if this was a cancer image that was incorrect from radiology? And you could say, well, maybe it's the eyes, maybe it's the ears, maybe it's the chain, if you look very carefully along the side. It turns out the model that was created wasn't determining husky and wolf, it was detecting snow. It had nothing to do with the intention of the way the model was created. Without this application to understand what the model was looking at, you never would have known. If you're in the finance industry trying to hand out loans, maybe it makes a model based on how long you're on TikTok. It has nothing to do with your financial background. Now you're giving out loans based on things that are totally irrelevant. So the previous methods of doing this are just expensive, time-consuming, and never-ending. If you've ever had to take care of equations in business process or in factories, it's like a baby. You have to constantly tend them. So data lives in one location, and the compute power lives in another, and it just takes time and money to keep shuffling them back and forth. But there are newer ways to do this. These newer methods leverage computer chips that are at the edge. They're in your car, they're in your coffee machines now, they're in your refrigerator. Information is everywhere, and the ability to make a decision is everywhere. So now in this new architecture, what we're able to do is push the machine learning model to the chip. You can make the decision at the place where something's happening. You have a self-driving car, what does it do at the intersection? It can make a decision. It doesn't have to go back to the internet. Just outside, the water sprinklers were on here at 2 p.m. If you had a sensor in the ground, you could understand whether or not the ground was wet or dry. It can make a decision based on that. So when the model's at the edge, you can also customize the decision by region. If you're gonna have self-driving cars, you'd probably have different rules in China than you would in France, than you would in North America. And maybe in upper state New York, in the middle of winter, you'd have suggestions at night to be careful because of black ice if you've never driven there before. You don't want to drive off the road. So back to the vision about NeuroThink. Recently, Brian faced a question about why we are not doing just software, but we're putting software on top of hardware and investing in expensive hardware. Because a lot of applications just go on top of large cloud service providers. But we all know what's possible when a technology company is unified and they put the software and hardware together. In fact, most of you are either using that device now or it's in your pocket, right? This company knew that they had to put the software and hardware together. And now this is a digital twin of your life. It's not just a phone anymore. It's not even just a camera, it's your life. They knew where that was going. We know that we also have to do that. So we've been focusing on 5 pillars to build out our platform. We want it to be streamlined. We need it to be innovative, has to be secure. We have to have edge to cloud. I talked about the edge devices. I talked about the compute power and bringing those together. And then we also need to develop a neighborhood for the data scientists. This year alone, we have a lot of compute power, and it is fast. So 4 petaflops, what is that? If each calculation was a kilometer, we could go back and forth to the moon 500 million times in 1 second. That's how many calculations we can do on our software, on our servers. But we need to make it accessible. We need to make sure we use it more than 1% of the time, like I talked about earlier. We have to be able to use it 95% of the time, which means getting a lot of people on and doing it securely. So what we start with are the powerful GPUs. We partner with NVIDIA and VMware to virtualize that solution. We customize the process, and then we can efficiently and effectively offer access to make amazing models, but then also retrain those large, powerful models that I talked about earlier. Those will be on our platform too. We securely offer each user their own containerized instance. This is through Kubernetes, and we built out our own UI UX to develop and train the models. Our product is the machine learning experience. It's not a layer on top of some storage platform. So we also have a sneak peek at the interface. This interface is going to allow us to manage the machine learning, access persistent data on fast SSD drives, remember the instances that were run, along with the parameters, allow you to promote your best model, and then export that so you can go put it to use, because that's the intention of all this, is to be able to go use the models. This interface looks nothing like you would see if you went to one of the existing providers and saw the myriad of screens, installation steps, and settings that you have to go through just to get your work started. And if you're a data scientist, you don't want to be spending your time doing that. So NeuroThink is going to be publicly available in 2022, but we're going to have limited access available this year. If you're interested, contact us at info@neurothink.io. Thanks, and we'll see you at 6 o'clock up at the Vista.